Problem number 28. So given the following expression is equal to 0, this one, find the value of a to the power 2000 plus 2010 plus a plus 1. So what's the idea here? Looking at this, probably you may want to find the value of a. So there are 4 values of a. It's like 4th degree polynomial. And then you want to find that a to one of these. And that should like that's a interesting problem actually. So like this polynomial could have 4 different values like roots, and then you put those values into this expression, and then each of them will give you the same result basically. Yeah. So what I'm going to do is, this is also like very common idea. First let me solve the problem, and then I will show you where that idea comes from, or you can just see that immediately. So like the first question that I'm going to you should be asking to yourself is a equal to 1? It cannot be equal to 1, right? If you plug 1, it's like 1 1 1 1 5. So like this expression becomes 5. So it's a is not 1. So which means I can just multiply. So like which means a minus 1, that the difference is not equal to 0. I'll just multiply both sides of the expression by a minus 1. The given expression, a4 plus a3 a squared plus a plus 1 is a minus 1 times 0. So here we still have 0. I need to open the parentheses here. So if I multiply by a, all these terms will be raised 1 power of a. So that becomes like a5, a3, a4, a3, a squared, a. And then minus 1. When you multiply by minus 1, you get a4, a3, a squared, a minus 1 is equal to 0. You see that this part of the expression is 0. So powers of a 4 3 2 1, and then subtract 4 3 2 1, so that's 0. What we have is a to the power 5 minus 1 is 0, or in other words, a5 is 1. So now you can rewrite this expression as so a to the power 2000 is just like a to the power 5 to the power 400 plus this is a5 to the power 402 and plus 1. So since this is 1, this is 1, the final result is 3. So now comes the natural question. So a is not equal to 1, and how come the result of this expression is equal to 3? So it turns out the roots of this equation, they are all like complex numbers. Yes, they are all, they should be complex numbers. And then when you have these complex numbers, the powers of those complex numbers end up to have the sum of 3. Like these two have sum 2, and then with these 3, 1 is 3. So everything starts with the following identity. So this is the identity that everybody should know. So what is the factorization of a to the power n minus 1? That's a minus 1. So 1 is one of the roots, like one very first, like immediate root. And then the rest is the factorization is an minus 1, an minus 2, so on up to 1. So the most primitive way that we have used is this a cubed minus 1 is a minus 1, a squared plus a plus 1. Or if you do a 4 minus 1, it's still a minus 1. And then you have a cube plus a square plus a plus 1. This part can be factorized further, but this identity is true for all of them. So when you look at this a4, a3, you should immediately see this expression. So if you multiply by a minus 1, you get a 5 minus 1. So that's the key point of this problem. Then when you know this, you can just find the value of the given expression.